Hey there guys, I'm Chris and I'm one of the creators of PyroRL, which is an RL environment tailored for wildfire evacuation. Our code is all open source and built on top of the Gymnasium API standard. Today, I'll review how to start with our environment and run through some sample code, and you guys can feel free to follow along by going to the quick start page on our documentation website. So, I'm going to keep switching kind of back and forth here between the web browser and my code editor, but if you go to my code editor here, I have some sample code set up, and I also have a Python virtual environment ready. And what I'll do is first create a new project and install PyroRL by running pip install PyroRL. So we can give it some time here to download all the necessary dependencies. And so that's kind of the first step, is just making sure that you have the package properly installed, and we'll give it a little bit of time here, and it looks like it was successfully installed. So that's great. So before we actually go deeper into the code, I also wanted to switch back and talk a little bit about the modeling behind the package. And I think the best way to do that is by looking at this GIF of one of the simulations. So at a high level, we modeled the problem of wildfire evacuation on a grid world. Now, there are several populated areas across the grid, as you can see with kind of like this darker blue color. And there are also evacuation paths here in yellow that connect these populated areas and lead outside of the grid. Finally, wildfires start at random locations on the map and spread stochastically over time. And the goal is to evacuate the populated areas before they or the evacuation paths are burned down. So with that quick intro now, we can dig into the code. And we'll specifically look at some code examples here from the examples folder on GitHub. I particularly looked at the code sample in intro.py, and we can switch that because I just copy and pasted it over here in VS Code to make it easy. So the first step, of course, is just defining your PyroRL environment, and there are 6 required parameters. So first, you want to define the number of rows and columns in the dimensions of your grid world here. You then want to define the list of populated areas, which we have as an array of XY coordinates. We also have a list of paths where each path itself is a list of XY coordinates. And finally, we have this variable here, which is a dictionary that maps paths to which populated areas are allowed to use those paths. And that effectively defines our action space, right? So the action space consists of both the populated area and then, of course, the path that it is taking to try to evacuate, if it does try to evacuate. So here we have all of the parameters hard-coded. In the documentation, you'll also have functionality that allows you to randomly generate a grid just by providing the number of rows, columns, and populated areas you want. And afterwards, we just define each of those as keyword arguments, and then we can run gymnasium.make here with the PyroRL environment name argument, and we get our environment. So once we have this object, we can basically set up a simple loop of this environment as you would do with any OpenAI gym or Gymnasium environment that you've seen before. So we reset the environment, and then for a certain number of time steps, we can then sample an action from the action space. We can take a step with that action and obtain an observation, the reward, whether we're in a terminated state in the environment or not, etc. Here we also have functionality to be able to actually render the environment, so it'll open a Pygame window and you can see the state of the populated areas and the wildfires. And in this case too, we're just also printing the reward. We also have this function, which is great, called generate GIF, which actually is able to, every time you kind of call render, will save all of the images of each of the grid states at that moment. And then at the end, we'll kind of stitch them together into a final GIF. So I'm going to clear my terminal here really quickly, and then we can run this to kind of get a better glimpse into what's happening. So again, it'll set up the environment, and if we give it a little bit of time, what we'll see is, and we can just give it a quick second here to kind of load up. So we can see that we have our 10 by 10 grid world, and this is kind of at time step 1, taking an action, being able to observe where exactly the grid world is in that time state, and then we can exit out of this as well. And once we exit out of it, it'll then open the next time step state and kind of see exactly what's happening. As you can see, we have more kind of populated areas that are evacuating. And, we can also go back to our terminal. We can see that it's printing the reward here. And if we continue to just kind of step through, of course, there's also a mode where you can just kind of save the images and not have to click through this. And that's why I'm only running it for 10 time steps. what ends up happening is after we kind of come to that completion, we'll close out of that Pygame window, the program ends, and we're also left with just this GIF here for training, and you can see that we're able to stitch together all of the time steps. So yeah, that's about the core of PyroRL. We also have a lot more examples where you can randomly, again, generate your grid. We're also able to integrate with other RL libraries like stable baselines, and so if you have any questions, feel free to go to our docs and reach out to us through email. So yeah, thanks so much.